Hi everybody, Mrs. Logus here. I'll be taking you through all the ACT prep questions related to quadrilaterals for the Chapter 7 review packet. Let's start here with, I guess, technically number 1 of this, but it's not labeled with a number, and that's okay. In parallelogram ABCD, AC is a diagonal, and the measure of ABC, right here, is 40 degrees. The measure of ACD, right here, is 57 degrees, and my goal is to find CAD, which is right here. Now, there's a lot of ways that you can approach this problem. You could think about that if this angle is 40 degrees right here, we stick with blue. If this is 40 degrees, this angle across the way also has to be 40 degrees because one property of a parallelogram is both pairs of opposite angles are congruent. So that is helpful here. And then what you could do is you could do 40 plus 57 and subtract from 180. So you could do 180 minus 40 minus 57. And if you do that, you would get the answer of D, 83. That is one way you can do the problem. You also could remember that consecutive angles are supplementary. So if this is 40 degrees, this entire angle has to be 140 degrees. And if you do 140 minus 57, you get that this angle is 83. And if this is 83, this is 83 as well because of alternate interior angles being congruent. That's another way. Even another way you could do this problem is if you recognize that these angles are supplementary as well. You could say that if this is 40, this entire angle is 140. And then if this is 57, this is 57 because of alternate interior. So either way, any of the three, you would get the answer of D, 83 degrees. For trapezoid ABCD, it's given that AB is parallel to CD, and the measures of the interior angles are distinct, and the measure of D is X degrees. What is the degree measure of A in terms of X? Well, what's very helpful for a trapezoid is that this pair of angles and this pair of angles, by definition, are supplementary. So that means that together they equal 180 degrees. So it means that this angle right here must be 180 degrees minus the other angle of X. The answer is F. Just as a note to help you study anyway, this direction are not supplementary, and this direction also are not supplementary. That's only true for a parallelogram, not a trapezoid. In quadrilateral PQRS, sides PS and QR are parallel for what value of X? So let me extend these lines, and some things we learned in semester 1 will be helpful. So picture those as the parallel lines and picture this as your transversal. We're looking at this angle and this angle right here. In order for these two lines to be parallel, notice that the two red angles are touching. The red angles are touching the parallel lines. Notice that. So I don't necessarily know that this is 112 because we don't know if this is a parallelogram yet. But what we do know is there's been a kind of a common theme with a lot of these questions is if you have same side interior angles, these two are supplementary. So if this is 70, this angle has to be 180 minus 70 or 110. So what value of X must make it parallel? In order for these lines to truly be parallel, this angle would have to be 70 and this angle would have to be 110, so that together, same side interior are supplementary. In the standard XY coordinate plane, 3 of the vertices of a rectangle are shown. Which of the following is the 4th vertex of the rectangle? Well, let's connect what we have for visual purposes. So we're trying to figure out what the rectangle looks like. I'm going to try this first. So let's try this. If you are looking at this side of the rectangle, this side of the rectangle has to be the exact same length. And so we could use distance formula or slope to help us. So this one goes up 1, 2 units over 1, 2, 3 units, up 2 over 3. So if we did the same thing here, we go up 1, 2 units over 1, 2, 3 units. So that point right there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, down 3. 9, negative 3. So the answer is J. Last one, in the figure, ABCD is a trapezoid. E lies on the line AD, and the angle measures R is marked. What is the measure of angle CDB? So we're trying to find CDB. We're trying to find this one right here. Okay, so the key to this problem is a few things. First, I noticed that this angle is 100, and they're both along this straight line. So it means that this entire angle has to be 80 degrees because you're doing 180 minus 100. So if that entire angle is 180, what I notice is then angle 80 here is equal to this angle 80 here. So that means that this is an isosceles trapezoid because we have the base angles being congruent. And if those base angles are congruent, it means that your top angles are congruent as well. So it means that this entire angle has to be 180 minus 80. So this entire top angle has to be 100 degrees. So if you take 100 degrees and subtract it from 25, or 25 from 100, you get that this angle here is 75 degrees. And if that angle is 75, and there's a lot of ways to do this, but if we look at this triangle now, the one I'm highlighting, if we have 75 and 80 and add them up and subtract from 180, because that's a triangle sum, we have that this angle here is also, let me use a different color, is, let's do green. This angle is 25 degrees, but we also knew that because these are alternate interior angles because of the parallel lines. Either way, the answer for the red angle, angle CDB, has to be the entirety of the 80 degrees here minus 25 degrees. If we do 80 minus 25, we get the answer of H, 55 degrees. What you could have also done is said if this whole thing was 80 degrees, this angle up here must be 100 degrees. So you do 100 plus this 25 and then subtract from 180 and you would get 55 there either way. So there's a lot of good stuff in here. You could look at the triangle sum. You could use the fact that these angles are supplementary. You could use alternate interior angles. There's a lot of ways that you can get the answer of H, 55 degrees. Okay, I hope that this video was helpful. Feel free to rewatch at any point. So my answers were D, F, D, J, and H. Thank you so much.